Hello again. In these next couple of videos, I'm going to cover how to use tools that can search and manipulate files. Now, this is a big area to cover, which is why I'm breaking it up, and it's one of the more important things that you can do in bioinformatics. And the tool we're going to start with is actually my favorite tool, and it's called Grep. What Grep stands for is Global Regular Expression Printer. Now, what that is doing is you're going to give it an expression, a regular expression, which is like a pattern, and it's going to search through a file or an input for this pattern. And whenever it finds that on a line, it's going to print that line back to you on standard out. So there are a lot of cases that you might use this, and you can also customize it with different options to suit your needs, which is why I find it like the Swiss Army knife of tools. And I'm going to start with a basic usage example of Grep. And to do that, we're going to take a look at our contigs again. So the contigs.fasta file, if you forget where that is, it's going to be in your example_assembly directory that you had downloaded before. So here I am in my home directory, and I'm doing an ls just to find it, and you can see right here, example assembly. So I'm just going to go and head right in with autocomplete. Yes. And I'm going to go ahead and do another ls. So you'll see it right here. Here are our contigs sitting right there, all happy. I'll just go ahead and peek inside. I'll use head for this because why not? This will just show me the first 10 lines. And you'll see that the first line is this right here. Notice that we've got this greater than sign right here. That denotes the header for our contig. And you're going to have one or more contigs. You're definitely going to probably have more than one contig for most assemblies anyway. So there's going to be a lot of them in here. So what if I wanted to see just the headers of all these contigs in our assembly? Now I could use something like more or less and open this up like so and just start going down and down and just, I guess, writing it down or something or copy and pasting it. But that's going to take forever. So this is not really something that you would want to do. And I'm just going to go ahead and clear the screen. So instead of doing that, we get to use our tool Grep. Now it would start off like this. You're going to type in Grep, the command, and give it a space. And the first argument you give it is the pattern that you would like to search for. And I'm going to give it this. Notice that I'm surrounding that greater than sign in quotations. And this is because this sign means something special in Linux. So I don't want it to mean that. I want it to mean just the character, the greater than sign. So to do that, you can surround something in a quotation, and that will allow you to have it be more its literal meaning. Also, you are allowed to now have spaces here because that's considered still one argument. So if you ever need to have spaces somehow in an argument without it meaning separate arguments, you can do something like this because now this is still considered one argument. It's one string of characters as an argument. This is also useful if you're looking for a couple of words side by side, separated by a space. You can do that with Grep if you do something like this. But anyway, I'm not gonna do that. I'm just gonna use this greater than sign right here. And remember, this is going to start each header. So it's gonna be the beginning of each header, and that means if I'm searching for this, it should be that Grep will return the lines where this matches, and that's going to correspond to the headers. So we should only get those back instead of the ATCGs. So the next thing you are going to give it is a file. So I'm going to go ahead and give it that contigs.fasta. Again, I am just auto-completing. And I'll hit enter. All right, it just went by really fast. That's because there are a lot of contigs in this file, so it just sort of floods your screen for a second. And now, as you can see, it returned only the lines that matched this character. And you'll see it's kind of nifty. The match will be in red. So you can kind of see where it found that match before returning the line. Okay, so that's a really basic example, but I think you can start seeing where this is useful. But what if you wanted to count this instead? What if you just wanted to know how many contigs were inside of this file? Well, instead of having to now count this line by line, we can give it an option. So if I'll just hit the up arrow key to recover my original command instead of having to retype this. I'm going to go over here. Alternatively, instead of having to go over here like this, you can use Control A and E to cycle to the beginning or the end of your command. So if I do Control E, it gets me to the end. If I do Control A, it gets me to the beginning. So that could be a useful way to get to where you're going a little more quickly. So anyway, I'm adding this right here, this -C. And what this option will do is instead of returning each of those matches, it's going to have like an internal counter that counts each of these matches once per line, which means if your thing matches more than once per line, let's say 2 or 3, it will only count that as one match. So keep that in mind. There are some limitations to grep. There are ways to get around that too, but I won't talk about it in this video. So -C is going to count them and return a final count at the end, which is kind of what I'm looking for right now. So I'm just going to make this small change right here and then hit enter. And you'll see that now instead of getting all those lines back, I'm going to just get a nice little convenient count. So I know that there are 5,634, which actually you could have cheated and just looked at the last contig, because this is just going to show you the count of each of the contigs. What current contig it is. So the last contig is going to be called 5,634. So it's kind of like a nice confirmation that this lined up. This is for spades. I don't know about other assemblers. They might not have the name of the count of the contig in it. So this is just a very specific example, but I just thought you should know. And I'm going to go ahead and just clear the screen. So why don't we go ahead and look at annotations instead, because each of the lines in a GFF should correspond to an annotation. So we can use this now to search to that, because it's a very crowded file. It's not very easy to go through and to search for patterns. Also because the last column is where you're going to get the information about what it is, what the annotation is, because it'll show you like the product and stuff in it. So just trying to find it in there is like searching for a needle in the haystack. It'd be much easier if we had a tool that allowed us to just return the things that were interesting to us, and that's what we're going to do now. So I'm going to go ahead and just cd into Proco report. That was an example directory that I had created for you, just to kind of see what kinds of annotations this assembly might have. And I'm in particular interested in this one because this GFF file is going to contain the annotations. And what I will do is grep, and I don't know, oxidase. Now, I don't need the quotations in this case because there's nothing special about this command right here. I'm not adding anything else to this pattern. There are no spaces, there's no special characters, but I do this just out of habit, and maybe it's a good thing to get into just in case you might include something special. So I just always add it, and then that was the pattern, so now I have to give it the file, and so I'm going to autocomplete to this.gff, and then I'm going to hit enter. Alright, so I'm getting a bunch of stuff back, and here's one of the limitations again with grep when it comes to long lines, because the lines are going to break. You're going to have them wrap around to the other side. So it's actually kind of hard for us to see what this did, but what it did do is that when it found that annotation, that line that had that oxidase in it, it's going to return it. And you'll see right here in red, which is pretty nifty, the times in which it found oxidase. So if you're really interested in oxidase, then here's your way of finding it, and you can really give it any pattern. If you're ever concerned about whether or not this thing is capitalized, we can, I'm just using the up arrow key to get this back, you can give it an additional option, -I, and this just means case insensitive. So if I ever had a capitalized oxidase, or any kind of combination of lowercase and capital letters, it's going to not care about it and just return it for me. It didn't have to be the exact match. Because if you don't give it that -I, it needs to exactly equal the string that you give it or the pattern that you give it. It's not. It does care about case. It's case sensitive by default. All right, I'm just going to press the up arrow key again. So another way to kind of narrow this down, because there's a lot of other text in here, maybe you're just interested in the product that it found, which would be like the protein or something. Well, we can find a way to make a pattern that will just match this part right here. Because notice that for each of these, when there is a successful annotation, it's going to say product, like right here, product equals, followed by the name of the product, and then that's the last thing at the line. Then it just sort of then it goes on to the new line. So we can use this to our advantage to come up with some sort of regular expression to match this. Now, regular expressions can be a bit complex when you're starting out, so I'm not going to go into detail about what all these mean, but I'll give you a basic regular expression and just kind of talk about the character that I use to denote that. So what I'm doing is going back here to modify my pattern portion. And I'm starting with product equals. In fact, we can just do this as to start out to see if this works. And yeah, it is. And oh, actually, there's a bunch in here. So what this is doing right now is just streaming through them all. But yeah, okay, this first part is going to just match product equals. I haven't done anything else in here. Now I press the up arrow key to get this back. I can keep going with this. So I can do this instead. So product equals, and then a period followed by this little asterisk. And these two things are actually special. So some of the characters in your pattern actually have a special meaning. So again, I guess you can't really easily escape the special meaning of these things. So the period in this case means any character. It'll match any character. And then the asterisk is going to mean, well, it's a modifier, so it will modify what came before it. So it modifies this period, and what it says is match it 0, 1, or more times. So that means it's going to match any number of characters following my initial pattern, which is right here. So the end result is that it's going to find product equals, and if it does find it, then it's going to also find the characters that follow it. So for instance, it would find the hypothetical protein over here. It's going to just keep matching, 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 matching till the end of the line, then it's done. So then it just finishes matching. And I'm going to go ahead and just hit enter to show you what I mean. Again, a bunch of stuff. So there you go. Now you can see that it is matching the rest of that using this pattern. There are all kinds of things you can do with regular expressions. They're incredibly powerful. I'm not going to cover it right now, but I encourage you to look into it. Now I can finally modify this with an additional option right here, the O option. And what this is going to do is it's only going to output the matches that it finds. This isn't particularly useful if you're just matching with a simple word, but now that we're using a pattern, we can match all kinds of interesting and different things. So I'm going to now just show the things in red when I hit enter. And as you can see, it's only matching now this particular portion of the line. So it's kind of convenient because now you're just grabbing that little bit of information that you find most useful. And there are ways to trim this away. I won't get into that right now, but just know that there are ways and that this is a pretty useful command, so keep that in mind. I might talk about it again in the future. And the last thing I want to cover briefly is that there's another option. Let's say that you want to look inside of a compressed file. Well, in cases like that, you don't want to use grep without any options because grep tries to look for text characters and stuff. Well, when something's compressed, it's going to kind of have all kinds of different characters, but they don't mean what they are. Well, anyway, the point is don't use grep on something that's compressed. But we can use something to modify grep so that it does work on something compressed. And the reason I'm bringing this all up is because of read files, you know, the FASTQs. Why don't we go ahead and look at those FASTQs, and I'll talk about what we can do to kind of search through them. So I'm just going to clear this screen, and I'm going to CD up a couple levels because that is where our home directory should hopefully be located. But I mean, you could alternatively just use CD on its own and hit enter. You should be able to get back to your home directory. And I'm kind of hoping that's where you're putting this because we're going to look inside of those example reads from a while back. So just go back to your home directory, look for this directory, and change into it. I'm doing an ls. And here are the two FASTQ files. So again, notice that there's a .gz. That is denoting that these FASTQ files are compressed right now. What we can use to search through it is this right here, this -z, grep space -z. And what this will do is modify grep so that it will decompress the file and then look through it for the pattern that we're looking for. So that's pretty much what we would want to do. Now there's a shorthand version of this that I use far more. It is zgrep. Anyway, so zgrep is the same exact thing. It just saves you a couple extra keystrokes. So I just use this instead because it's a special usage case. You're not going to use it a lot, so you might as well just have a quick way of doing it when you have to use it. So here we go, zgrep, and then I can give it a pattern. So why don't we, because this can potentially be a big file, why don't we just give it a simple thing? So I'm going to just count, I'm going to count the number of times the @ sign appears in this. Now for FASTQ files, each new read is going to start with an @ sign. So that @ sign can be used just like the greater than sign with the contigs.fasta. So we can use it to count the number of reads that exists in this file. So I'm going to go ahead and just do that, -C, and I'm going to do this. And then I'm going to go ahead and just give it one of these. I'm going to autocomplete. I guess I'll do the R1s. It doesn't really matter in this case. So now it's all set up. Zgrep allows me to search inside of this because it's gzipped, it's compressed. And now I'm going to count the number of times this @ sign appears, and that should give me the count of reads that exist in here. And then I'm going to hit enter. All right, we got 500. That's sort of disappointing, but that's because I really, really truncated this before I gave it to you guys. So you only actually have 500 reads in here. That's definitely not assembly quality. You couldn't just assemble a whole genome out of 500 reads, but you get the picture. You can use this now whenever you get your reads, probably like real reads this time, to count the number of reads that you have. So it's kind of a convenient little thing. And I think I'll leave off with this. I have more advanced usages of grep that I would like to cover at some point, and another useful tool called sed. And hopefully I'll show you how to string these all together using something called piping. So until next time.